If you found this video, you've probably heard of the latest text-to-image AI generation model, Stable Diffusion. Stable Diffusion was released earlier this week on Monday, August 22nd, and this has been the first publicly released text-to-image AI model of its kind. So we've seen a couple others like DALL-E and Midjourney, but those models were either on limited release or they were always, cloud API querying platforms where you can request from the model, but you can't actually download the weights and run it locally yourself. So Stable Diffusion is the first model to do that, where they actually posted the model weights available for download. And like I said, on Monday when it was released, I did make a video explaining with the code they provided, how we can actually download that model and run the code to produce our own images. There was one drawback with that at the time. Unless you had a very, very expensive graphics card with something like 40 gigabytes of VRAM, you weren't going to be able to generate the highest resolution images that you may have seen in either the blog posts that they put out or in other people's generations that have gone viral on social media and things. So you may have been a bit disappointed in the resolution that you're getting with depending on just the standard consumer graphics card that you have. So in my case, I have a 3080 with 10 gigabytes of VRAM, and I was able to previously generate 512 by 768 was the max image size that I was able to get out of that first, the code that we went over in the first video. And since then, I've discovered another GitHub repository here from a user called Jay Quesnell that actually put out another version of, or actually an add-on to the Stable Diffusion code to actually run the same exact model using the same amount of VRAM, but actually upscale that image substantially. So I've been able to get 1024 by 1024 and even greater than that resolution-wise in some of these images, and I think it is a roundabout way that we get to that resolution, but the image turns out much cleaner, much crisper, and actually comparable to the ones that you may have seen online before. So with that said, let's jump right into it. If you followed that first video that I put out, I will put a timestamp on the screen here so that you can jump ahead to the part of the video that's relevant to you. Like I said, this is an add-on to that code, so if you were able to get that up and running already, you won't need to re-pull any new code regarding the first bit here, other than just this add-on. So I'll put a timestamp with when we're actually doing this add-on portion. But I am going to start from the beginning. I know there were some people that were running into some issues with the repo in the first video, so I'm going to run through that again and start all the way from the beginning, installing all of the different tools that you'll need to actually run this model. Okay, so the GitHub repository we'll be using is the same one as in the last video. It is from this user Elstein. I found this one to be much better than, or there's a few improvements made from the repository that Stable Diffusion, or that the Stability AI put out themselves. And I'm going to link this repository in the video description at a certain point in time, so that when you're running the code and following along with the video, you can run the same exact code as I am here. So we're just going to go ahead and download this by clicking on the green code icon and downloading zip. Then I'll go in the downloads folder, and we'll do the same with this add-on. I'll put a link in the description as well, but this repository called text-to-image HD. Okay, and then next we'll actually download the model weights themselves. So to get these, you can go to Stable Diffusion Hugging Face, and it should be the first link here. It's from compviz/Stable Diffusion, and if you scroll down here, we'll be interested in this v1.4. There's actually two links for it. We'll be using the one that is under the Stable Diffusion GitHub tab. So if you click on 1.4 original, and then we will be using this 1.4.checkpoint file. There is another file here called full EMA. This one's about 3 gigabytes bigger. I'm actually not sure exactly what this file is for. I have tried to run them both, and they tend to produce pretty similar outputs. So I'm just going to stick with this first file. But if you are familiar with the purpose of this file, do leave a comment below explaining that if you'd like. Yeah, just curious to see what that full EMA file is for. They started by just posting this first one, and then this one was later added. But I've used this first file so far. So we've kicked off that download. It is a 4 GB file, like I said, so my expected time here is about 20 minutes, so we will just let that run. The next thing we'll need is we're going to download Python, and we'll actually use an Anaconda distribution of Python. And Python is just the programming language that is going to run all of this code. So I will go to anaconda.org, download Anaconda, and then download here. I'm actually going to cancel this one. It looks like I already have this executable downloaded, so I'm just going to find that in my downloads folder. So I have this executable here. As soon as you download that executable, you can double click and run that and kick off this installation. And we'll just go through all the defaults. We can let that run. Another thing we'll need, if you have never written any code before, you'll need just a code editor. I imagine most of you will have a code editor already installed, but I really wanted to start all the way from the beginning for the complete beginner here, so I'm going to download Sublime Text, which is just a text editor for coding. But obviously any editor that you prefer will work just fine here. So we can go to sublimetext.com and download, or I'm actually just going to use this download for Windows here. Yes, okay, so that is downloading. Once we have Anaconda downloaded, we can start to actually create our programming environment, or our Anaconda environment, which is defined by this environment YAML file in the repository. One thing to note about this file, this is basically just defining all of the packages and dependencies that we'll need to run this code, and it's organized nicely with all the versions laid out in specified here in this single file. One thing to notice here is these git commands at the bottom. So in this case, instead of installing packages from something like conda or pip, these are actually coming straight from GitHub, or straight from repositories on GitHub. So to call or to install from using git commands, we'll need to install git, or download git and install it so that we can actually call those commands. I believe it is, yeah, git-scm.com. And we can click download for Windows. And this 64-bit in my case for my machine. Okay, so it looks like our Sublime Text is done. We'll open up that executable. I believe this one's quick. Again, we can go through the defaults here and finish. Okay, so now that this git file is done downloading, we can run that to install it. And again, we can go through all of the defaults here. This will be important to note where git is downloading. It will generally be in your C drive program files, but just keep that in mind for a step just after this. That will be useful to know. Again, just click through all the defaults here. And looks like our Anaconda is complete, so we can finish that out. We don't need the tutorial or the getting started. And we don't need to view the release notes, we can finish. So now we have our Anaconda distribution downloaded. If you have not used git before, or if you've not done that installation before, you'll notice that if you type git here, you get basically a message telling you that git is not recognized as an internal or external command. If that is the case, you're going to have to navigate to your Windows menu, type in env, and edit the system environment variables. Along the top ribbon here, if you click Advanced and then Environment Variables, and you go to this path variable and click edit. Basically here we just need to see that that Git executable file in your path. So the way to do that is, as I mentioned, this wherever your Git installed on your file system, if you go in my case it was in the program files and in this Git folder, you should see this bin folder that contains the executable file. So if you just copy that path name there and click in your environment variables window, new, paste that path name and just enter /git.exe. So this will basically tell your system how to call Git, or where that git.exe lives. So we can minimize that for now. And then if you close out your Anaconda prompt, reopen a new one, and type Git again, you should see this menu that I get here once that is added to your path. So the next thing to do is to actually create our conda environment. So there's instructions in the GitHub repository how to do this. We're just looking for that create command, which is here. I'm actually going to just rename my environment since I've already created an environment from this before. So in our downloads folder, we actually haven't extracted the repository yet, so that's one step we'll have to do first. So in your downloads folder, now that you have these two repositories downloaded, you can actually just move those zip files to a location where you'd like to actually run the code from. I'm going to move them to my documents, and I have this empty Stable Diffusion video folder set up. So we'll go from there and just extract both of these repositories. And I'm going to extract both of them in this Stable Diffusion video folder. Okay, so we can now delete these zip files, leaving just and we have this long ID on the Stable Diffusion repo just because we downloaded it from a point-in-time GitHub commit instead of the from the end of the branch directly. So I'm just going to rename this to call it Stable Diffusion main. So if you look inside here, you should see that environment YAML file that I mentioned that defines all of the packages that you need to install. So I am going to open this up. So we just downloaded Sublime Text, so we should be able to open this up in our text editor here. And you can definitely leave this name as LDM. The only reason I'm changing this is because I already have an environment called LDM and I'd like to create a fresh version for the video. So I'll just call this, let's see, just LDM1 and save that. And we can then run that. So I copied this from the GitHub page, conda environment create from that YAML file. Actually, I need to close that out. Terminate, yes. One thing I forgot to do is I actually need to navigate to this directory in my file system. So we can type cd. So I just clicked on the right of the folder I'd like to navigate to, copied the file path, and type cd for change directory, space, and paste, Control V, and enter. So now you should see your file path basically update to be within this folder location that is where all the code lives. This is like your main root directory for the GitHub repository. And now we can, from here, we can call the conda environment create. So it should be able to access this environment file from here. So this is doing quite a few installations here. Again, reading through this environment file, there's quite a few packages here, and some of them are actually quite large. So just give this some time. It may take, I think it's taken me, 10 or so minutes in the past, and I've feedback in the previous video, it could be a bit longer depending on your machine. So you'll get to a point here where you'll have installing pip dependencies or something similar at the bottom of the window, and you'll just have a spinning icon with no progress bar showing you if it's almost done or anything. That will run for a while. Just give it some time to finish that installation and activate your conda environment. So I'll let this run here while this is creating. We still have some time left on our model as well. But one thing we can do in the meantime is we can go to this add-on library. So this is the point in the video where if you have already used Stable Diffusion in the past, this is the point where we're finally getting to this add-on code. So if you've run Stable Diffusion but you haven't done this high-resolution text-to-image HD code, this is the point to resume from. So we've already downloaded this repository. If you haven't, just download this alongside the previous repository we mentioned. And you see the two steps here are, well, first have a working repository of Stable Diffusion, which everybody should have at this point. And next, copy this text-to-image HD PY file into the scripts folder. So we can do that. If I back up one, we have these two repositories side by side now. I can go into the HD one and just copy that Python file that it is referring to, and like it says, just paste it into the scripts folder. Okay, the next thing we will need to do is this step 3, download the appropriate release of Real ESR GAN. This is basically the upsampling program that is, it's unrelated to Stable Diffusion. It was actually the latest releases back in April. So this basically takes your image and is able to upsample it. So the way this will work in practice is the Stable Diffusion model will still, take in your prompt and generate the maximum image size you can. Say it's 512 by 512, for example. It will then chop that image into 4, and it will use the image-to-image feature to upsample using this program here. So I'm just going to download this Windows version here. Yeah, so it will basically stitch those, upsample those 4 quadrants, and then it'll stitch them together to give you one single high resolution image. Okay, so now that this file has finished downloading, I will just pull up the file location. It's in my downloads folder currently. We want to just basically move it to the same folder as our, in my case, the Stable Diffusion video folder. So now we have all 3 side by side, and actually this needs to go in the root. So you see in the instructions here, this needs to be extracted into the root of your Stable Diffusion repository, which all that means is just the highest level folder inside this Stable Diffusion main. So I will move it there and extract it there. Okay, so now you should see the main file that will be called from those extracted files is this executable file here. So this is basically, there will be a subprocess in the Python code that references this file, and it needs to live exactly in this location, in your root directory of your main Stable Diffusion repo. You can also just delete that zip out again. We won't need that anymore. And we will come back when the conda environment and model conda environment is done creating and the model is done downloading. Looks like we have about 13 minutes left. Okay, so now that the Anaconda environment is finished creating and installing all those packages, and our model has successfully downloaded, we can actually go on and activate our conda environment. So conda activate, in my case it's LDM1 is what I called it, but yours will just be conda activate LDM if you didn't change that name. And you should see, after you run conda activate LDM, in parentheses on the left side here, LDM2 to indicate that you are within that environment. The next thing you'll need to do is just go to that downloaded model and drag that into the directory as well. So inside this main, Stable Diffusion root directory, we'll go into models, into LDM, and then from here we need to create a folder called Stable Diffusion V1, and that name needs to be exactly those characters, Stable Diffusion V1, because that's where the code will actually look to find the model. So I'll go ahead and I will just move the model there, and then we'll also need to actually just rename the model. So the name that the code is expecting is just model.ckpt or .checkpoint. So now that we've renamed it and created that folder, just a couple other things we'll need to do. So we can try to run the Python code. I'm going to open up a regular command prompt as well, aside from this Anaconda prompt. So the way I did that was just Windows and then type in com command, and you should see the command prompt come up. Not Python. So from here we want to just run NVIDIA-SMI-L, and I'll refresh it every 3 seconds. So this will basically give you a snapshot of your graphics cards every 3 seconds. So I have 4 cards on this machine here. One of them has a bit of memory used up because I'm running my my display and my recording software and whatnot, but the rest of them should be free. And you see these 2 have 10 gigabytes free. This one has 8, so I will be wanting to use one of these 10 gigabyte cards so that I have the maximum capacity for VRAM when we actually run the model. And PyTorch will default to your I guess best performing graphics card anyway, so we won't have to mess with any parameters to select that card. I will open up the code here in our editor. I guess I can try to run it first here, but there is going to be one error that I'm expecting, I believe I will hit. So to actually run the code, we'll call scripts. So we need to run Python, and inside the scripts folder we need to call this text to image HD. So from our root we can do scripts / text to image HD and enter. And this is the error that I was expecting. No module named watermark. So I'll open up the code here to explain what this is. So if you take a look here, we are importing this function called watermark encoder. I'm not sure where this actually comes from. I'm not sure if this is a module that the author of the repository created or where exactly they're expecting to be importing this from. I looked, it doesn't seem to be found in either pip or conda, so I think the intention was to put like an invisible watermark on each photo so that someone could, in theory, detect whether it was generated by a machine or maybe it would be able to detect that it was generated by Stable Diffusion. I guess I'm not sure exactly. And if anyone is familiar with where that library comes from, definitely leave a comment, and I will include that in the video description if someone is able to find that, so that we can actually run the code, as the author intended this here with the watermark. But unfortunately, just because I don't know where that package is coming from, I'm gonna have to just comment that out for now. So we'll have to comment out everywhere that this package is called so that we're not running into module import errors. So this put watermark function we won't need. I'll just control shift and / to do a multi-line comment there. And we also just want to find everywhere where this is called. So we need to comment out line 365, 366, and then also whenever this is called. which is down here in line 506, which is where the put watermark actually happened. So after commenting all those, I believe it was 5 things out, I'll save that file, and we can try this one more time. Okay, so now this is asking me for a prompt. This first test run, we really just want to try to get a sense of how much VRAM can we get away with. So the size of the image that we are specifying here is just the size of the first image before upsampling. And after upsampling, you should expect the image to be 4 times, well, on each dimension 2 times the size. So a 512 by 512 would get upscaled to 1024 by 1024, which is, in terms of area, or I guess resolution, 4 times larger, and so each dimension multiplied by 2. So let's give it a prompt here. A prompt I believe that I've ran before that was yielded some interesting results. Let's do mountain landscape. Okay, so I will run that. I ran mountain landscape, wavy, psychedelic art, vibrant colors. And we'll see what this gives us. Again, monitoring the GPU usage here, we'll see how much VRAM. I think the default parameters that this will use is 512 by 512, so we'll see how close or how much I can get away with in terms of VRAM here. And you see this starting to rise. Okay, so it looks like we are pretty close to the capacity here, actually very close. I thought I was able to get a bit more out of the model before, so we can try upping it just a bit. Okay, so I will let this run through, and we'll pick up once this is done. Okay, so in this folder here, so from the main Stable Diffusion main, if you click Outputs, and then you should see a text-to-image HD samples folder now, and then samples, then you'll see your images. So I just ran one image here. The 3 images that are generated are the first image, which is just 512 by 512 in my case, or whatever dimensions are specified by the parameters. And you can see the dimensions in the kind of hover text there, 512 by 512. And then the U is the upsampled version, so you see 1024 by 1024. And the UD is, I guess, a more detailed version of that. I believe that's what the D stands for. Someone can, correct me if I'm wrong there. So what you end up getting here is a much better improvement in terms of resolution. So if I were to, I guess, open these up side by side, the first and second files. Let's do them one by one. So if I were to zoom to this same aspect ratio to give to compare resolution here, you can just see, how much more crisp, especially, I don't know, I'm looking at this kind of mountain shape here, just how much more crisp we are on the right side in the higher resolution image. So let me generate, you go back and just take a look at, play around with the parameters and see what we can get away with in terms of VRAM usage. So the way you can do this is by opening up, I like to just edit the code itself. You can, use the same parameters, like -W and -H to specify the width and the height, for example. I like to just open up the code so I can see exactly what I'm editing here. So I'm going to go ahead and do that. Okay, so there's going to be a chunk of code near the beginning of the file where you see all these parser.add arguments. These are where all of the default parameters are specified. So obviously the prompt doesn't have a default. The output directory you can change if you want. Specifically, I'll be interested in the sampling steps you can play around with. I actually find 150 to be a pretty nice number. I think it works well. This iterations, this is basically the number of photos to generate. So with a default of 1, we generated obviously just 1 photo. And this will be like different photos every time. So if you have an interesting prompt that you want to explore further, bump this up to 10, let it run for a while, and you'll have all kinds of different results. I usually do something like 3 to 5 or higher once I find a prompt that I like. This 512 is what I want to experiment with, so I want to change this to 576. I believe this needs to be in multiples of 64. So you can enter something like 500 here. That's at least how the first Stable Diffusion model worked. So yeah, multiples of 64 here. If you see that, if you're hitting like an out-of-memory error, you're going to have to decrease this these height and width parameters until you can actually run it, and then that will just be the memory limit on your resolution. But for me, I think I can get away with 576. And yeah, I won't change anything else here. I'll mention the seed. The seed is basically so that you can get reproducible images, because there is some randomness that happens with the sampling. So if you want to make sure that you can run the same prompts twice and get the same results, you should set a seed here. And then if you want to use a different seed, you can change this number to anything else. But default is 42. This is just the models directory. I think any of this other stuff probably won't need to adjust. So let me try to run. We'll do just 3 more of these, and we'll let it run. And actually, let me change the seed here so that we don't regenerate that first image again. Let's change it to 41. Okay, so we'll do this same prompt. Okay, so I've run a few more prompts with the 576 by 576 resolution, and I pulled out just a few of my favorites here that I wanted to show. So you can see here the version without the U will always be 576 square, and then the upsampled version is 1152 by 1152, which is quite a nice resolution image, especially compared to just running the Stable Diffusion model itself. So this one here, I entered something like humanoid robot, and this one I mainly just wanted to show because I think it's a good demonstration of the difference in resolution. So can compare these side by side here and just take a look at the difference in like the detail around the eye, for example. You can see it's just we have much cleaner resolution on the right side here, which is very cool that this just happened all through upsampling. So it's almost like the brain of the model understands what it wants to generate, but we're just not giving it enough bandwidth to do so. So the rest can really be filled in with that upsampling technique. So I'll just go through each here. This one was a prompt that was in the GitHub repository. I don't remember exactly what it was, but you can search the examples there. I just wanted to test that out. But yeah, just the detail on the dress here and in the flowers, you can see, and in the clouds here, much higher resolution than you'd get in the first version of the repository. This one here was again higher resolution on the right. I believe this was a Greek island with Santorini architecture, ocean view with sailboats, painted in the style of Claude Monet. So you can really get super detailed with these prompts, and I was really happy with how this one turned out. I mean, this is like if you had this painting hanging on a wall in your cabin, I think nobody would know that it was generated by an AI, which is super cool that it's really becoming indistinguishable from true art. You know, this image is completely generated by the prompt and never, you know, nothing like it, or I guess the same image doesn't exist anywhere online. So I think that's, you know, really cool that this is just a completely unique, indistinguishable piece of art in my opinion. So a couple of the last ones. This was let's see, this was a city landscape on Mars with starships at sunset. I said with starships. I wanted to see if it would include the SpaceX Starship in the photo, and it looks like it kind of has this little pillar here, or whatever you want to call it, that is in the same shape as a starship, but I don't really see the rocket that I was hoping for. Moving on to this one here was, I believe it was a mountainous national park photography with aurora borealis over a reflective lake and vibrant colors. This one, compared to the lower resolution, you can really see the detail starts coming out in like the grain of this rock here. You can really see the difference in detail down in the lower part of this image, where the detail of the rock actually really jumps out now that we have the higher resolution. And this last one, this was the same prompt, one of the same prompt that I generated in the demo. Can't remember exactly what it was, but the mountain landscape with wavy psychedelic style vibrant colors, something along those lines. Yeah, and I think this turned out pretty cool. So those are just some prompts that I've been playing around with. Again, you can run these forever. It's a very entertaining model to use. I'd be interested to hear what you guys come up with. If you have any prompts that, you know, maybe you don't have the type of machine necessary to be able to actually run this yourself. Maybe if you want to leave a couple prompt ideas in the comments, I can go through and choose the ones that I like best, and I'll run those and maybe post them in a future video, or just go through the coolest ones in a future video at least. So that'll be all for this one. Hope this was a comprehensive tutorial. If you have any questions, feel free to leave them in the comments below as well. Thanks for watching. Hope you enjoyed, and I'll see you guys in the next one.